Yeah, hi. Thank you very much, Abby. Thank you very much, Emma. It was really good, really nice to start out with that history. I'll try to talk a little bit about VR in education and some of the work we've been doing at the Virtual Learning Lab, where we have about 14 employees doing research related to immersive VR and behavior change and educational interventions. So yeah, so Abby gave a history of VR. I think in terms of thinking about VR becoming mainstream in education, and there's been a lot. There's been at least a lot of media coverage related to VR, specifically really exploding in 2017 with VR, where it was dubbed the year of VR. And you had a lot of experts predicting that it would be mainstream within education. If we look at some of the statistics about the use of VR and AR headsets over the last couple of years, you can see that it is increasing. Maybe you don't hear so much about this hype, but I do think it's slowly becoming more mainstream, and you see it really infiltrating different areas. An interesting statistic is that when you look at different industries, education is actually the area where there's the highest gap between demand and supply. So a lot of companies are interested in using VR in their training. A lot of educational institutions and stakeholders are interested in using VR in their education, but there's really this gap because there's really not a lot of really good content out there. So I think there is a lot of potential to have VR really become more mainstream as we go forward. And what we realized a few years ago was that in order for this to happen, we really need to take a step back and start to answer some important questions, things such as where's the evidence? Where's the theory? Who should be using this? How should it be used? What are the challenges? How should VR be integrated into educational interventions? When should it be used and why? So we've tried to do some research about this, and of course, a lot of other people have. What I'll talk about today is specifically where's the theory. I'll talk about a theoretical model that describes how immersive VR can lead to learning outcomes. And then when. I think Balanson nicely in his book, he said that VR should be safe for scenarios that are too expensive, dangerous, impossible, or impractical in the real world. At least I'll talk about 4 scenarios or 4 examples of projects that we have where we look at one that's too expensive to do in the real world, one that's too dangerous, and a couple that are too impossible, and then try to link this to the theory. So if we look at this research field, I did a search on Scopus last year as part of an article I was writing, where I looked for immersive VR and terms such as learn, train, teach. And you can see the number of articles per year has just really exploded. And if you look this year, I'm sure it's all the way up here. It's probably twice as much. We've also done a lot of research in this field. I think we've published like 20 articles in the last 4 years or so. I was looking recently, and we've had over 30 experiments where we've had over 4,000 people through our experiments where we've measured something related to learning or behavior change. So based on all this, we've developed a theoretical model because we really felt like that was something that was missing. And we published this in Educational Psychology Review this year. It's called the Cognitive Affective Model of Immersive Learning, CAML. And it's a theoretical research-based model of learning in immersive virtual reality. So basically, in our model, we highlight presence and agency as the key psychological factors that really differentiate VR from other learning platforms, or at least are stronger, you have higher presence and higher agency in VR. So presence is this feeling that you are in the environment. Agency is this feeling that you control the environment. And you have a number of different technological factors, such as immersion, which can create higher presence. Control factors, so are you just a passive observer in the environment, or are you actually controlling things in the environment? And then representational fidelity. So there's obviously a number of other ones, but these are some of the main ones. And then in our model, we talk about how these 2 affordances actually lead to learning outcomes through a number of different cognitive and affective factors, such as interest, motivation, and so on. And each of these are built on existing motivation and learning theories. But I'll talk about an example where we use a scenario that's too expensive in the real world. We send middle school students to a virtual field trip to Greenland to learn about climate change. And I'll talk about how this can increase interest and thereby increase conceptual knowledge. I'll talk about a scenario that's too dangerous in the real world. So for university students, learning about safety before they go into a lab and how this increases self-efficacy and ultimately transfer. I'll talk about a scenario that's not possible in the real world. So how embodying people into an older avatar can help them gain a better understanding of why it might be necessary to be vaccinated related to COVID-19. And then I'll talk about a scenario that's not possible in the real world, where we try to show people the consequences of their food choices by sending them 30 years forward in time in the Rocky Mountains National Park. Cool. All right, so yeah. So the first example here is an inquiry-based science learning intervention, which we used here in Denmark. It was a national intervention. We had 6 different lessons. So you started out by getting a fake news article, and then you had to travel to Greenland as a research team. So we sent people to Greenland virtually in groups of 4. They had to investigate some of the factors related to climate change, and then they had 4 sessions when they came back to prepare a presentation to the UN panel, which was the other students in their class and the teacher. So students were either sent on this virtual field trip in HMD or as a 2D video. And what we did was we measured conceptual knowledge after they were sent on the virtual field trip. And what you can see here is that in the immediate post-test, the immersive VR group or the head-mounted display group scored higher than the video group, but it was not significant. If I move over here to after 18 days, so this whole intervention took about 18 days because there were 6 sessions. What you see happening is that the immersive VR group actually now, after 18 days, scored significantly higher than the 2D video group. So we measure a number of different factors, including presence, enjoyment, and interest, where you can see that the HMD group scored significantly higher than the video group on all of these. And then we did a structural equation model to understand this process. So what you see happening here is there's 2 paths. Immersive VR can lead to higher presence, which can lead to more enjoyment and can lead to higher scores on the retention test. And this was not significant between immersive VR and the video. But what you see happening is people who are more present, they enjoy the field trip more, and then they learn more. The more interesting thing here is looking here at the other path. Immersion led to more presence, which led to more interest, which led to better scores on the long-term retention test. So what's happening is that people in immersive VR are more present. This causes them to be more interested. And this likely causes them to put more time on task or put more effort into the following lessons, which then leads to better learning outcomes. So what's really interesting about this is that lots of times when we do research related to immersive VR compared to other media, we don't really find learning effects immediately, but we always find motivational interest effects. So people are more motivated in immersive VR. And what we find here is that if you this might lead to more time on task and ultimately better learning. So I think it's interesting. If we go to the next example here, this is an example, a paper we published in 2019 with Borgud and Richard Mayer. Basically, Borgud is responsible for engineering students at the University of Aarhus, and he trains them in safety before they go into the lab. So we divided his cohort into 3 different groups where they had the same content, but presented in an immersive VR simulation, desktop simulation, or as a manual. And what we see happening, here you can see some pictures of the students. Yeah, and what we measured self-efficacy pre and post the training intervention, and we see that the manual group did not change on self-efficacy, but the desktop group did slightly, and then the immersive VR group did a lot, and this was significantly higher than the manual. So people are gaining more self-efficacy in their ability to deal with risky situations inside the lab. There were no differences on the retention test, so this was a multiple choice test. And I highlight this just because if we want to teach people about factual knowledge, then immersive VR is not necessarily the best place to do that. But if we look at transfer, so this is real behavior 10 days afterwards in the real lab, we blind marked people, and there was a scenario where they got acid on their skin and they had to react appropriately. The immersive VR group scored significantly higher than the booklet group here. So basically, we're able to train people to react to realistic, dangerous scenarios in immersive VR. So I think that's quite exciting. If I turn our attention to the third example here, we just got this new grant from EIT Health in collaboration with ETH Zurich and a colleague of mine who works in behavior change with vaccines. We're interested in seeing if we can actually embody people into older avatars if this will influence their understanding of the social benefits of being vaccinated. So we had a 2x2 experiment here, where you're either embodied as a younger avatar or as an older avatar matched to your gender. And then you go into the doctor's office and you either get individual information about why you should get vaccinated to help yourself, or social plus individual, why you should do it to help society. And what's really interesting about this project in terms of the potential with VR and VR research is that we did this online. And within 1 month, we collected, it was only Oculus Quest users, and we collected 687 responses within a month. 312 of them we had to throw out because they had a 100% vaccine intention. They were already going to get vaccinated. So we pre-registered this, so we had to throw those out, but we still had 375 respondents. And it was a huge success, mostly young males. But basically what you can see related to vaccine hesitancy is that from the pre-test, which is the orange line here, to the post-test, which is the green line, there was a significant increase for all conditions. We also measured after a week, which it increased even further, but that could just be because people are getting more and more sick of corona. And in terms of the different conditions, we just got this data yesterday, so we actually have a meeting at 2 o'clock to discuss this. But basically, it looks like there could be an interaction, but it's not significant. So it'll be interesting to see what happens there. The last example is one I'm really excited about, because here we're trying to show people the consequences of their food choices on the environment. And basically, you start this simulation out in a living room where you select foods. Then you're sent to the Rocky Mountains National Park, where you experience nature. And then you travel with this national park ranger 30 years in time forward. And she shows you what would happen if everyone in the United States continues to eat as they do today. So this is only for American people. We're going to run it online. And then you go back to the living room, select foods based on, you get some education related to different foods and their impact on nature. And then you select new foods, and then you go back to this environment again, and either if you chose better foods, you save the environment. If you chose worse foods, it gets even worse. And the interesting thing here is this whole thing that you have control over what happens. So it's modeled based on if everyone made the same choices you made. So this is also in terms of self-regulation, which we found in lots of our research that VR experiences can be very engaging, but it's really important to actually give people a chance to reflect over what they've experienced, because if you don't give them this chance to reflect either in the simulation or afterwards, then sometimes it becomes more of an entertainment experience rather than a learning experience. So I think those are some examples. Hopefully I was able to convey some of it, and I have a lot of more information. So if you're interested in that, please just look at our lab or the VAX website or our profile. Yeah, thank you.